All right, so we're still looking on the June 2014 Regents exam. We finished up the Part 1s on Tuesday. We've gone through some of the Part 2s, 3s, 4s already. Ones that we had already kind of seen, we kind of skipped over, and we're looking at ones that we hadn't seen up to this point yet. And so there's just a couple more that we're going to look at, and then we're going to get into the next exam. We had skipped over number 28 because it was just another normal distribution question. And again, with normal distribution, where are we looking to? The bell curve on our reference table, right? They wanted to know that a mean is 63 inches, a standard deviation is 2. There's 450 girls in the school. Determine how many are shorter than 60 inches. So we find out what score the 60 represents. This is shorter than, so we're going to add up all the percentages below that. Exponential regression equation, we had seen one of those already. I believe we did this one with the absolute value equation turning into 2. The conversion of radians to degrees, what do you multiply by to get radians into degrees? 180 degrees over pi radians. So we're going to end up multiplying the 2.5 by 180 and then dividing it by pi, and then they wanted that to the nearest minute. Did we look at that one? I want to look at this one then just because of the nearest minute concept. We've talked about it before. I know we talked about it in class. I think it was last week. But I want to bring that point back up again. So we have 2.5 radian, and which is why I stress in class, does pi define radian measure? No. Here we have a radian measure that doesn't have pi. Okay, pi does not define radian measure. The little degree symbol not being there defines radian measure. So we have 2.5 radian. We are going to multiply it by 180 degrees over pi radian so that our units of radian cancel out. And then we're just going to simply go into our calculator. We're going to take that 2.5, multiply it by 180, and then divide that 450 by pi. And so I get 143.2394488 degrees. But as I highlight up here, they wanted this to the nearest minute. So we don't want to be in decimal degrees. We want to be in degrees, minutes, and seconds. Where do I go in the calculator to change just this regular decimal notation into the degrees, minutes, and seconds? The angle menu. Yep, second apps, and then option number 4 is going to turn us into degrees, minutes, and seconds. Okay. So we have 143 degrees, and currently we have 14 minutes. So what we've got to ask is 22 seconds enough to round us up to the next minute? Well, how many seconds do we need to go up to the next minute? 30 or more, because there's 30 seconds in 1 minute. So if we have more than half, then we can go up. But is 22 enough to bring us up? Nope. So we keep it at 14 minutes. 143 degrees and 14 minutes. Okay. So that angle menu, second apps, gives us our degrees, minutes, and seconds conversions. It's been asked quite often on the last few Regents. You know, instead of to the nearest tenth of a degree or to the nearest degree, they'll ask to the nearest minutes. Okay, so something you want to be aware of. Would only be a 1-point error on this one. If you had the 143.2394488, obviously it's a correct answer. It's just not in the form that they want it, so you would have lost a point on that one. Okay. 32, multiplying by a conjugate. So what is the conjugate of x plus yi? X minus yi. And did we look at that one? Yeah, we looked at that one. We looked at this one, correct? Solving the logs, we changed log bacon and eggs back into what? Be happy. Did we look at 34? Okay, let's. Again, we haven't done this yet. They're asking me to solve it how? Algebraically. So algebraically is the only way I'm going to get 2 full credits out of this. Can I solve any equation graphically, though? I absolutely can. I can solve any equation graphically. Okay? So even though we haven't done this yet, Can I graph this and find out where it's equal to 0 and at least get half credit? I absolutely can. So let's show what we need to do to get the half credit on this for doing it graphically. Folks, you should never, ever leave an equation blank. If it says to solve it algebraically, fine. I'll bite the bullet and I'll lose half credit, but I'm going to solve it graphically and get half credit. Okay? So, what mode do I need to be in? Obviously, this is trig because we have secant. Secant is a trig ratio. So mode is a concern for us. And as we read, it's kind of clear we need to be in what mode? We need to be in degree mode, okay? Which is kind of not the standard for trig. Usually if we've got a trig equation like this, they want us to be in radian, but that's fine. And then I'm going to go to y equals. Okay. And how you solve any equation graphically is that you take whatever on the left-hand side of the equation, type that into y1. Whatever on the other side of the equation, you type that into y2. And then you find out where they do what? Where they intersect. You find out where they intersect. Now, do I need a y1 and a y2 for this one, though? No, because the y2 is just going to be 0. So I'm just going to type in secant x minus radical 2 and find where it crosses what? The what axis? The x-axis. We're just going to find the zeros of this. Could I also do this, though? Could I move the radical 2 over here and have secant x equals radical 2? I absolutely could do that. Would not make a difference. And it's actually, that's the way I'm going to do it. I'm going to move that over so I can see two distinct graphs and see where they intersect. Okay? So I'm going to do a little bit of work here. I'm going to say secant x equals radical 2. Okay? And I'm going to be very clear of what I'm doing here because I'm not solving this algebraically. So I'm going to highlight this side right here and say I'm going to put this into y1. I'm going to highlight this side over here and say I'm going to put this into y2. Okay? So I go into my calculator and I'm going to do that. The question is, how do we type in secant? 1 divided by cosine x. 1 divided by cosine x is secant. My y2, I'm just going to simply type in the radical 2. Okay? And before I graph, we normally go to a zoom 6, but in this case, I'm going right directly to my window because it's very clear here that they told me they want the x values to go from where to where? 0 to 360. So I'm going to go into my window. The x minimum, well, that's going to be my 0. The x maximum, that's going to be what? 360. I'm not going to go all the way from 0 to 360 scaling by ones, though. I'm going to scale it by the 4 quadrants. How many degrees marks off every quadrant? 90 degrees. I'm going to scale it out by 90 degrees. So I'm going to see 4 markers. That first one is 90, 180, 270, and then that last one will be out at 360. The y values, well, we're really concerned with where it's going to be equal to what? Radical 2. Well, radical 2 is a little bit greater than 1, but not quite 2, is it? So if it's not quite 2, how about we go from negative 2 up to positive 2 on our y's? And are we okay scaling that by ones? Yeah. So I'm going to graph it up now. Here's secant x. So right there is secant x, and right there is the line at radical 2. Okay? Now the question is these things really shouldn't be there. It's really not part of the graph. But how does our calculator graph? Our calculator plays connected dots. So there's this dot up here and this dot down here that the calculator is connecting up. But those lines are not supposed to be there. Okay? Those lines represent a value that the graph gets really, really close to, but it will never touch. It represents a what? It's an asymptote. It's an asymptote. Secant is not defined at 90 degrees. And again, you told me already, secant is 1 over what? Cosine. Well, what is the cosine of 90 degrees? From our table, cosine of 90 was what? 0. So the secant of 90 is really 1 over the cosine of 90. Well, the cosine of 90 is 0. We can't divide by 0, can we? So 90 is undefined. That's an asymptote right there for us. So it's not an answer. Okay? So what I'm going to do right now then is I'm going to provide a rough sketch of what my calculator has. So I'm going to set up this graph. I'm going to mark that off at 90, 180, 270, and out here at the end at 360. And this does not need to be an exact graph. I'm going to then scale 1, 2, -1, -2. I'm going to kind of indicate my asymptote here at 90 and at 270. And then my graph kind of looked like this over here. In between here, it kind of looked like a parabola. And then it kind of finished up like that over there, didn't it? Kind of looked like that, right? Okay. And I'm going to define this as y equals secant x. And then we had this line running across right here, and that line represented y equals radical 2. And then what I'm going to do is I'm going to, with a nice big clear X, indicate the two spots where they intersect. And then I am going to provide the coordinate of the points where they intersect. And how are we going to find those points? Second, trace. Option number 5, intersection. Okay. Well, is y1 1 over cosine x the first curve? Yep, absolutely it is. So I hit enter. And then is y2, the square root of 2, is that my second curve? It absolutely is, so I'm going to hit enter. And then they want me to move into a guess. Well, my first guess, I'm going to move it over to here. Right about there. And I'm going to hit enter. And it tells me that they intersect when x equals what? 45 degrees. And folks, that 1.414236 is just my y value of what? Radical 2. So they intersect at 45 degrees. They're both equal to radical 2. And then I'm going to do that same process all over again. Second trace. Option number 5. Is y1 the first curve? Yes. Is y2 the second curve? Yes. My guess, I want to bring it way over here to the right now. Close enough. We find out they also intersect at 315 degrees and radical 2. Okay, so now I'm going to summarize it up. X equals 45 degrees and 315 degrees. Okay, now folks, looking at this one here, this was only, was this a 2-pointer? Are we still in part 2s? So this was only a 2-point question. Now, did we do a lot of work to get 1 point? We did a lot of work to get 1 point here, didn't we? But, did we get points? Versus leaving it blank? Because I'm not sure how to solve it algebraically yet? A lot better than nothing, isn't it? Okay, this one's a very easy one to solve. Very easy one for us to solve. So are we all right with the work I've got here? Can I go ahead and erase that? Okay, now again, was this a very accurate graph? No precision at all here, right? This was just a rough sketch, right? But I highlighted all the points. I got half credit out of this. I'm going to go ahead and erase this now, except for my secant x equals radical 2. And I'm going to show you how to solve this algebraically now. Okay, well, what we don't like here is the secant. We're really not as comfortable with secant as we are with what? As we are with cosine x, right? Well, we know that secant and cosine are what of each other? They're reciprocals of each other, aren't they? So if secant x is equal to radical 2, then what does cosine x have to be equal to? It's reciprocal, right? 1 over radical 2. Well, it's the beginning of the year. We were talking about that. We don't really like that there, do we? How do we get rid of that radical in the bottom? Yeah, we're going to multiply by 1. Just the variation of 1 is radical 2 over 2. Okay. And we get that cosine x equals what? Radical 2 over radical 4, which we see better as 2. Okay, that's kind of an important value for us on our table, isn't it? We had a very important angle that was equal to radical 2 over 2. 45-degree angle. Okay, so x equals 45 degrees is one of our angles, right? But we had 2 when we solved it graphically, right? Where are we getting that second one? Well, we're getting that second one from all students take calculus. Notice here, cosine is equal to a positive value. Well, where is cosine positive? Quadrants 1 and quadrants 4. Well, we found our first quadrant reference angle, didn't we? Well, now we just need to put that reference angle into quadrant 4. How do I put 45 degrees over into quadrant 4? 360 minus. 360 minus 45, which is 315 degrees. With the amount of time this year that we're going to spend on trig equations, which I'm hoping I can get 3 days next week on trig equations, with a little bit of time on trig equations, I'm really crossing my fingers that your trig equation falls into part 1 with the multiple choice, or like this one here in part 2. I'm really hoping you don't get a quadratic. But through the reviews, we're going to run into a quadratic trig equation, okay, which is just like a normal quadratic equation. You can solve it by factoring, quadratic formula, or completing the square. It's just that instead of having an x squared, you're going to have like a sine squared and a sine x, or a cosine squared and a cosine x. Okay? So cross your fingers, trig equation, part 1 or part 2. Okay? We don't want to end up getting half credit on a part 4 as opposed to taking half credit on a part 2. Okay? And I would strongly recommend for you as well, regentsprep.org. Okay, we're not going to have much time on trig equations or trig graphs. Go to regentsprep.org and look at their lessons on trig graphs and trig equations. Okay, and then please bring any questions back to me. But expose yourself a little more to them on there. Okay. Questions on this algebraically or graphically? Okay. We did do this one, right? Moved us to the left 1 and up 2. Yep. Did we look at this one? Good one to look at. What did we call this at the beginning of the year? Complex fraction, right? Because we had fractions within fractions. Okay. Well, do I want multiple numerators? No. So that was the first thing we did. We ignored the bottom and just said, I have 1 over 1 plus 3 over x. Well, I would really like to combine these two things together to get one single fraction. But what do I need to do if I'm going to add 2 fractions? What do I need to have? And what would that be up here? X, right? So I'm going to multiply this one by an x, top and bottom. And is that all I need to do? There is a 1 right there. There is. So we don't need to multiply by 1. That does nothing. Okay. So now can I go ahead and add these two? Yep, my common denominator remains what? X, but what do I get for a numerator now then? X plus 3. X plus 3. So now do I have one single numerator? Yep. Now let's do that same thing in the bottom. I have 1 over 1. I'm going to subtract the 5 over x. And I'm going to subtract the 24 over x squared. Well, what's my common denominator for the bottom? X squared, right? So this one over here needs an x squared, bottom and top. But this one only needs a what? Just an x to get the x squared. And how about the last one? Is that one all right? Yep, that one's all right. Okay, so my common denominator is now what? X squared. And what do I get out of a numerator? We got x squared minus 5x minus 24. So now do I have one single numerator divided by one single denominator? Yes. But we don't divide fractions. We multiply by the reciprocal. So we're going to take this x plus 3 over x and not divide, but multiply by what? X squared over, and what are we also going to do to that x squared minus 5x minus 24 as we're bringing it to the bottom? We're going to factor it, right? Tell me about my signs. Are they the same or are they different? Yeah, they got to be different. To multiply to get a negative number, they've got to be one positive and one negative. Okay, so what factors of 24 will subtract to give me a 5? Negative 5. Negative 8, positive 3. And so now before I multiply, what can I do? X plus 3's get canceled out. Anything else get canceled out? Yeah, because x squared means what? An x times an x. So this right here will cancel the square. What am I left with up top? X over x minus 8. X over x minus 8. Now, folks, I can't do this all in the calculator, but can I check it in the calculator? I can store any number I want as x and see what this would be equal to, and then type in this. And if I did it correctly, what will happen? They'll be the same. They'll be the same. Okay? I like seeing that one there. I think that's an easy question. Could we have handled complex fractions really in Algebra 1? Yeah, we did. All of this was done in Algebra 1. You added fractions. You subtracted fractions. You divided fractions. The only thing you didn't see in Algebra 1 was the top being together with the bottom. But you did all those individual steps in Algebra 1. We're just kind of putting it all together, but realizing I still want to take it in small parts. Okay? All right with that one? Moving on to the one I really wanted to see. Okay, it's been a while since we've seen this one here. We're very comfortable with quadratics, right? And how do we spot quadratics? An x squared. Well, this doesn't have an x. Well, it does have an x squared, but it has a higher power of x cubed. Well, we still want to solve it in a similar way. No matter how I solve the quadratic equation, what did we always do to it first? Standard form. What do we want to do here first? Standard form set equal to 0. So tell me what that would look like. X cubed plus 5x squared minus 20 equals 0. Okay. We still want to see if we can potentially factor. Okay, so what do we always look for first when we factor? Not a GCF here, is there? Okay, if that 20 had an x with it, then everything would have an x, but it doesn't. 4 and 5, there's nothing common between 4 and 5. There's not a GCF. It's obviously not dots. Why can it not be dots? 4 terms. Dots needs 2 terms. It can't be the trinomial because the trinomial needs 3 terms. We've got 4. What is our clue in with 4 terms without a GCF? Factor by grouping. I'm going to group these first 2 together. What can I factor out of those 2? X squared would leave me with what? X plus 5, right? Okay. How about these 2? Yeah, they're both negative, right? So let's bring out negative 4. And what would that leave me with? Yeah, X plus 5. So, folks, my 4 terms have now turned into 2 terms, right? The red group and the orange group, right? The 4 terms are now 2 terms. Well, is there now another GCF amongst these 2 terms? What did they both have in common? They share the x plus 5. But what's left when I take the x plus 5 from the red? X squared. What's left of the orange when I take away the x plus 5? The minus 4. Still equal to what? Yeah, still equal to 0. And now we use, what's that property when we set everything equal to 0? What's that called? What are these two things called? Two things that are getting multiplied together, they're called factors. And this over here is 0 factor property. The 0 factor property. Okay. And the 0 factor property says that if I've got any number of factors being set equal to 0, then I individually do what with each of them? Set them all individually equal to 0. So x plus 5 equals 0. X squared minus 4 equals 0. So over here I get x equals negative 5. Over here, can I factor that further? Yep, that's an x plus 2 and an x minus 2 equals 0. And so again, I would get an x plus 2 equals 0, x minus 2 equals 0, and then what would be the two answers I get from here? Negative 2 and x equals positive 2. So I summarize it all together. I think I have answers of negative 5, negative 2, and positive 2. But folks, we never just take for granted that they work. We need to check them all. We need to check them all. Okay, for time's sake tonight, they all work. Okay, but we need to store each one of them individually as x, type in our original equation, and make sure that they work. Okay, we got to make sure that they work. Okay, questions on that one? Okay. Okay, yep, I've got it recorded, and I'll have it on my big campus probably around like 9:30. Okay. All right with that one? Okay, what else do we have here? What's the probability formula? NCR, S to the R, F to the N minus R. What does N represent? Total number of, and in this case, no more than 2. These are horror movies, so how many horror movies she's going to rent? What's the R? Successes, right? Now they want no more than 2. So does that mean 2 up to 5 or 2 down to 0? 2 down to 0. So we're going to have to run this formula how many times? 3 times. And then what do we have to do with them after we find the 3 individuals? Add them together. You've got to add them together, and they want this to the nearest 100. This is the question that I was trying to find in class today. Okay? Forces. This is going to end up being a triangle application problem for us. The law of sines, law of cosines, area. Whenever you see forces, you're going to be using one of these things. So what do we have here? We have 2 forces of 40 pounds and 28 pounds acting upon an object. Okay, a car goes into the ditch. 1 tow truck's not enough to get it out. So we have to have 2 tow trucks hook up to this car. One's pulling kind of in this direction, the other's kind of pulling in this direction. That's what we have. The 2 tow trucks represent the 2 forces pulling this object out of a ditch. Okay? So we've got down here some objects. And one force of 28 pounds is pulling us this way. And another force of 40 pounds, notice how I made that one a little bit longer? Because it's a bigger force. Okay? So I have this 28-pound force and this 40-pound force acting on this object. Well, folks, where is that object actually going to go? Does it follow straight line to the 40-pound force? Does it follow straight line to the 28-pound force? Where does that object actually go? Kind of in between them. Now, is it going to go closer to the 40-pound force or closer to the 28-pound force? Closer to the 40. Why? Yeah, now if they were equal forces, if they were both 40, where would it go? Directly in the middle of them. But this one, the 40 is pulling a little bit harder, so it's going to go a little bit more in that direction right there. That kind of looks like a diagonal, doesn't it? Kind of looks like a diagonal of what kind of a figure? Yeah. So if we do this now, I recognize that I've got a parallelogram. Now, why did I use dotted lines out there and not solid lines? They're not the actual forces, are they? They're just line segments that we put in to represent the forces. So this one also measures 28. This one up here also measures 40. So folks, whenever you see forces, what are you going to be drawing? A parallelogram. Here's my two forces that are acting on the object. This diagonal is what we call the resultant force. That's where the object actually travels. But do I really need to be looking at the whole parallelogram, though? No, all I need is either the upper half or the lower half. And it now turns to a law of sines or a law of cosines problem. Okay? So two forces of 40 and 28 pounds act on an object. The angle between the two forces is 65. That's this whole angle right here. Now notice, I'm not going to label that as 65. Why am I not going to label it as 65? Because there's two different angles that make it up. And are they congruent? Absolutely not. But I am going to use the fact that this one is 65 to help me find this one up here. What do I know? What's the relationship between consecutive angles of a parallelogram? They're supplementary, right? So what's the supplement of 65 degrees? 100 and? Too much. 115 degrees. So is this one also down here 115 degrees? Yes, but I'm not going to worry about labeling it because I'm getting rid of it. Find the magnitude of the resultant force to the nearest pound. This is now a triangle application. This is law of sines or law of cosines. Why? I'd rather use law of sines. It's easier. I don't have a side angle pair here, do I? Okay. So what would the law of cosines tell me about resultant squared? What would resultant squared be equal to? (28 squared plus 40 squared times 28 and 40 cosine of that 115 degrees, right? And I'm going to let you guys go ahead and type that in. Once you type it in, you're then going to take the 1 of it, the square root, and we want this to the nearest pound. Okay, now folks, take a look here. Take a look, take a look. Smaller than 28, in between 28 and 40, larger than 40. It's got to be larger than 40. Why? It's across from the largest angle. This has got to be the largest side. So go ahead, calculate that, take the square root of it, tell me what you get to the nearest pound. $58. Verification on DJ's 58. Yes? 58. Are you in, what mode are you in, Maria? Kate, I'm sorry.
I didn't finish it.
Oh, okay. Easy enough. Okay, so R equals 58 pounds. We've got a 58-pound resultant. Now, folks, the resultant will most always be the largest one. The only time it wouldn't be larger than your other two forces are if your two forces are acting against each other at an obtuse angle. If they were acting at an obtuse angle, then the resultant would end up being the shorter diagonal of the parallelogram as opposed to being the longer one. Okay? So if the angle between them is obtuse, then it's not going to be the largest. Using this answer, so we're using the 58 that we rounded to. Using this answer, find the measure of the angle between the resultant and the smaller force. What was the smaller force, the 28 or the 40? Here's the resultant. Here's the 28. They want me to find that angle right there. Can I use law of cosines? Absolutely. Can I use law of sines? We're kind of iffy on using law of sines, though, for angles. But is this ambiguous? Why not? It's got to be the acute angle. Why? We already have 1 obtuse angle at 115. This has got to be the acute one. So let's use law of sines. It's easier. Okay, so 58. What is the angle across from the 58 resultant? The sine of 115. Answer that for me. It's not a right triangle. Okay? Yep. SOHCAHTOA is only if you've got a right triangle. So equals, we want to find that angle, I'm going to call this x. We want to find the sine of angle x down here. What side is across from that angle? The 40, right? Okay, so what times what divided by what? Sine 115 degrees divided by 58. I'll do that one. We want to make sure we're in what mode? Yep, we want to make sure we're in degrees. So 40 sine 115. Divide that by 58. Can that work? Can sine be 0.6? Yes, it just can't be greater than what or less than what? 1 or negative 1. So what do I do now? Inverse sine. Inverse sine of that. And they wanted to the nearest degree. 39 degrees. The measure of angle x is 39 degrees. Cross your fingers, guys. This is what you want. You want a force question. You want one of those questions that we talked about in class today. You want that to be your part 4 question. You want that to be your part 4. Okay. 6 points, but it's based on formulas that are completely given to me on the reference sheet. I just need to know which one to use and what to put into the formula. Okay. Questions on that? I want to keep going with short answers tonight with the time we've got remaining, but let's go to the next Regents exam. So this is what, June of 14? So we're looking probably at January of 14. Yep, January of 14. Let's work our way part 4 back in. So we'll start at 39 and work our way in. Solve this how? Algebraically. We're kind of stuck on this one. We're not going to be able to solve this one graphically. Because we can only graph what 2 log bases in our calculator? Natural log and common log. Well, is this necessarily a common log? No. We really got to be able to solve this one algebraically. Well, we solved log equations, didn't we? How many logs were we allowed on each side? Just 1 log, right? So we're looking at these 2 logs and saying, I've got to condense these 2 logs. And then I can convert from log form back to what? Exponential. Log bacon and eggs becomes be happy, right? Okay. So the question is how do I condense them? Well, it depends on how they're held together. These 2 are held together with what? Addition. Addition condenses down into what? Multiplication. So instead of having 2 log base x plus 3's, we're only going to have 1 log base x plus 3. And then what operation do I have to do with the 2x plus 3 and the x plus 5? Multiplication. So 2x plus 3 times x plus 5. And this is still equal to what? Still equal to 2, right? So now do I have 1 log? Yep, so folks, log bacon and eggs converts to what? Be happy. So what is my base? So x plus 3 to the what power? To the second power is going to have to be equal to what? 2x plus 3 times... Well, let's go ahead and multiply that out. What is this going to be when we FOIL it? 2x squared. 10x and 3x, though, is going to give me 13x. And then 3 and 5 is 15, right? So plus 15. What does it mean to do to square something? So let's do it over here as well. Let's FOIL this out. What's x times x? X squared. Altogether, we're going to have 6x plus 9 equals 2x squared plus 13x plus 15. So folks, if they've got a log equation in part 4, it can't just be a log equation. Once we get rid of the log, it's going to become a what? Quadratic. And now what do I need to do to this quadratic then? Yeah, so am I going to move everything to the left or everything to the right? Ultimately, does it matter? No. Why are we moving them to the right? We want to keep them positive, right? So let's go ahead and do that. We don't need to show every little step. You don't need to show multiplying or subtracting x squared from both sides. Subtracting 6x. If you need to, but you don't have to. So what is the 2x squared minus the 1x squared on the other side? So it's an x squared. I've got 13x, but I'm going to take away 6 of them, plus 7x. I got 15, but I'm going to take away 9. Not 6x, just 6 equals 0. But it's a nice quadratic. Can I factor that? What to? Say it louder, I can't hear you. Log bacon and eggs became be happy. The 2 was right there as the exponent. We squared it and multiplied it by itself. That's what happened to the 2, okay? Signs are going to be what when I factor this? Both positive. There's 2 factors that will give me 6. 1 and 6, 2 and 3. 6 and 1. Add to the 7. So folks, x equals -1 and x equals... Okay, folks, if you're done now, they caught you. We can't take it for granted. We got to check these, right? Okay. We can't take the log of what kind of number, folks? We can't take the log of a negative number. Remember, exponential functions, you couldn't cross the x-axis. Log functions, you can't cross the y-axis. We can't take the log of a negative number. We can't take the log of 0. So let's just look back up here. -6. What's 2 times -6? -12. What's -12 plus 3? Can I take the log of a negative value? No. This one's not going to work. But do I scribble it out? Do I erase it? No. I just show either one of 2 things. Put the line through the equal sign to say it can't work, or say reject x equals -6. It is a solution to this quadratic. It's just not a solution to the original log equation that we started with. -1. Is -1 going to work for us? Yeah, because what's -1 plus 3? 2. So we'd be looking at log base 2's. Negative 2 plus 3 would be 1. And over here, negative 1 plus 5 is 4. What's 1 times 4? Log base 2 of 4 equals 2. Yes? Because because 2 squared equals 4. Log bacon and eggs, you convert it back to be happy. 2 squared equals 4, so log base 2 of 4 is 2. Yes, the negative 1 works, but the negative 6 does not. Okay? Really can't solve this one graphically to try and fight our way through it. But, bare minimum, folks, I'm hoping that you can at least realize that these two logs need to come together as one, and then does that give you at least 1 point? Yes. Yes. And then hopefully you remember the log bacon and eggs and be happy. Is that going to give you a second point? Absolutely. So there's definitely partial credit we can get on this one, okay, if we can't remember to solve it all the way out. All right with that one? All right. 4-pointers. Put a smile on your face. Two sides of a parallelogram are 27 and 32. So here's my parallelogram. 27 and 27, 32 and 32. The included angle measures 48 degrees. Find the length of the longer diagonal. So shoot. What just happened to that 48 degrees? It got split. So are we going to be able to use the 48 degrees? Not directly, but I can use it indirectly to find this one. What does this one have to measure? 132. And now let's get rid of the parallelogram, because all I need is just a part of it, right? They want me to find this length right here. I'd really like to use law of sines. Can we? No. So we have to use. And what's the law of cosines going to tell me about x squared? What's x squared going to be equal to? The 27 squared plus 32 squared times the cosine of 132 degrees. Do we have to finish it out, guys? Can we just keep moving on? Okay, so we plug it in, we find our answer, we round it to the nearest centimeter. Okay? Good 4-pointer. Probability, let's do this one first. Let's do 36 first, and then I'll come back to 37. We kind of talked about a trig equation on the last exam, right? And I said, you know, kind of cross your fingers that it's in part 1 or part 2. Well, here it's in part 3, and it's a quadratic. How can you recognize the quadratic? Squared, right? Okay, so let's make this easier. Let's make this easier. Let's let y equal sine x. Because that's what we don't like here, right? We don't like the trig value being in there, the sine x. So let's get rid of it. And now if this were a theta, I'd say let x equal sine theta. But they've already got an x up here, so I don't want to say let x equal sine x. So let y equal sine x. So wherever there's a sine x, I'm going to replace it with what? A y. So this is 2y squared plus 5y equals 3. Now is it a more familiar quadratic to us? Standard form, what would it be? 2y squared plus 5y minus 3 equals 0. Something we haven't seen in a while. X method, right? Okay. Now, regardless of having a 2y squared, what do we have left and right? Not 2y, just y and y, right? Signs are going to be? So plus and a minus, but now these both have to get divided by what? The 2. Okay. What value gets dragged to the top? The 5. And what gets brought to the bottom? 2 times the 3, which is 6. Okay, so I've got 1 and 6. I've got 2 and 3. They both do an operation to give me 5. One of them adds to give me 5, the other one, which one do I need? I need the subtraction one. Why? Because it's a minus 3 again. So which one subtract to give me 5? Okay, so positive 1, negative 6, or positive 6, negative 1? Positive 6, negative 1. But 6 divided by 2 is what? 3. That's just a y plus 3. And over here, we can leave it as y minus 1/2. Or we can bring up the 2 and make it 2y minus 1. Okay. So, a little review of X method. That was nice. So, y plus 3 equals 0. 2y minus 1 equals 0. So y equals what? Negative 3. And over here, y equals what? 1/2. Of the 4 points, how many points do you think you have? You've got a strong 2. Depending on the rubric, you might have 3 here. You've definitely got 2 points. Okay. We kind of went away from the trig, but now we've got to bring it back, right? What did we say that y was equal to? So now we got to bring that sine x back in. So not y equals 3, but sine x equals 3. Sine x equals negative 3. Sine x equals 1/2. Are you guys starting to realize why I quiz you every day on that table of values? We've seen it twice tonight now, haven't we? Okay. Folks, can this first one happen? Can sine x be equal to, and regardless of the negative or positive, can it be equal to 3 over 1? No, because sine is the ratio of what side to what side? Opposite over hypotenuse. Well, can the opposite be longer than the hypotenuse? That can't happen. So we're going to reject this right off the bat. Boom. That can't happen. But can sine be 1/2? Yes. Where can sine be positive 1/2? 1 and 2. This is going to be in quadrants 1 and 2. And folks, I hope you don't need to go to your calculator. The sine of what angle is 1/2? 30 degrees. So x equals 30 degrees for quadrant 1. But how do I put that 30 degrees over into quadrant 2? 180 minus, which gives us 150. And now again, folks, I think I'm done. But I never move on to the next problem until I go back to the problem and make sure I have answered it. Have I answered this question? No. I have not answered this question. They want the answers in what? Radian. And my answers are in no issue. We know how to convert. What do I multiply by to convert? I've got to multiply by pi radian over 180 degrees. And then the same thing with the 150. I've got to multiply by pi radian over 180 degrees. So folks, all I need to do is just go into my calculator and take 30, divide it by 180 to get my reduced fractional answer. 30 over 180 becomes 1/6, but then where do I have to put that pi though? Up with the 1. 30 degrees is pi over 6 radian. And now let's do it with 150. 150 divided by 180 reduces down to 5 pi over 6. Now have I answered the question the way they wanted it? Have I checked them yet, though? No. So I am going to take pi over 6 and store it as x, and type in the original and make sure that it works. And again, for time's sake, yes, they both check in this case. Okay, but is it worth losing? Folks, if I did all this work and ended it with 30 and 150, everything was great, but I made a mistake, so I can't get a full 4 points. And can I take a tenth of a point off for what it really should be? No, I've got to take off a full point. You just lost 25% of that problem. We're not seeing that it needs to be in radian, and we gave an answer in degrees. Okay, so make sure you always go back and read. Have I answered the question appropriately? Okay, have I answered what they wanted? Okay? So give me just a couple minutes and let's look at this one. And again, just to review the problem, I'm not going to go through the calculation of it, but I just want you to set up the formulas for me. Tell me what we would do. Very little sunlight. The probability that a geranium planted there will flower is very slim. 0.28%. I'm sorry, 28% or 0.28 chance that it will seed. Sam planted 5 geraniums. Determine the probability to the nearest thousandth that at least 4 of the how many? Of the 5 will flower. It's not a given formula. You've got to show it. What is the formula? NCR. S to the R, F to the... You are not going to get a point for that. You will get the point when you then come down and tell me the formula and what the variables are equal to. How many geraniums are we planting? 5. We want at least, so that means 4 down to 0 or 4 up to 5? 4 up to 5. What is the probability that it will flower? 0.28. So what is the probability that it will not flower? 0.72. Now do you have a strong point? Yes. Okay, your other points now come in knowing that you've got to do this twice and you've got to add them together. But all you're going to show me is 5 combination 4 comma 5, 0.28 to the 4 comma 5, 0.72 to the 1 comma 0. Okay. You will then go to your calculator and get the value for exactly 4. You will get the probability of exactly 5. You will add them together, and then you will round it to 3 decimal places. Okay? Any question on those parts 3 or 4? I'm really glad we got that trig equation with the quadratic. 1 out of 3 times it's going to show up. Okay, 1 out of 3 times. What's that? They have to tell you in a case like this. Now, if it was the probability of flipping a coin, what's the probability you're going to flip heads? 1 out of 2. But in this case here, they came right out and told us the probability that a geranium planted will flower is 0.28. And so that's what they want. The probability that at least 4 will flower. So what is the probability that it will flower? 0.28. Okay? And they're always going to tell me the 1. So how did I get the other? Well, these two things have to add up to equal what? 1. They've got to add up to equal 1. So if one of them is 0.28, well, then I go into my calculator and I say, well, 1 minus 0.28 gives me 0.72. Okay? If one of them was 2/5, what would the other one have to be? Because 2/5 and 3/5 give you 5/5, which is 1. 2/3 and Well, if one is 2/3, the other would have to be 1/3. Why? 2/3 and 1/3 are 3/3, so 2/3 and 1/3. What if they said a 60% chance? What would the other percent chance have to be then? 40%. 60 and 40 add up to 100%. Okay? So they've always got to add up to 1. Okay? And quite often you've got to make sure you read really closely. Is this probability they give you always the S? No. We saw a couple when we were doing this lesson that sometimes they give you the F. Okay? Now, if you switch them, is that a 1-point computational error or a half-credit conceptual error? It's a half-credit conceptual, not realizing which your success and failure is. Okay? Good there? Very good. Hopefully we'll pick up next week with that then and go from there. Have a great one, guys.